Yeah, once again, very good morning to all of you. Today we need to discuss about heap and its operation. Heap is a very special type of binary tree, but you can understand that it's a binary tree, but it is called heap, and the reason is very interesting. It has a very special property. Heap is first of all, it's actually a numeric tree, and you actually have possible duplicate values in the tree, and you can actually consider them for building up a tree. So you can have duplicate in the heap. So what is the property? The first property you see is that the value of the root can be greater than or equal to value at the left or right. That means it not necessarily unique. All left, right, and root can be same value, but value of the node, if it is greater than the value of the left and right can be anything. It's not necessarily that left must be smaller than the root. You have seen in case of binary search tree, but in case of heap, left and right can be bigger or smaller. It doesn't really mean anything. But if the value of the node is greater than the value of the left and right, we call it max heap. Max heap means it's a heap. The maximum value of this entire heap is at the root. When we see other way around, is that if the value of the node is less than of the value of the left and right, it is called min heap. Min heap means, you can understand, this min heap means the minimum value is at the root. And we have two types of heap. Then we have a max heap and we have a min heap, and in between also we have min max heap. That means maximum value and minimum value both are represented in the same heap. Now, an example of a max heap you can see here. This is a root, and this is the left and the right. Left and right can be any value, but the root must be greater than the left and the right value. We call it max heap. One thing very important for you to take note is that heap must be a complete binary tree. You can understand complete binary tree means tree which is gets populated from left to right. So I will give you an example here. See here, this mean heap, this is a mean heap example, but you see 50 on the left, 46 on the right, and the minimum value is at the root. So mean heap means the minimum value is at the root, but this tree must be a complete binary tree. For example, you see the next example I'm showing you is very interesting because it says that it's not a heap. Why? 28 is the minimum value, fine. The left and the right is okay. But you can see it must be a complete binary tree, but this left is missing. On the right you have some value 29, but it is completely an invalid. Why? Because this is a binary tree, but it is not a heap. Why? Because it is not a complete binary tree. Complete binary tree means the left must be having a value. So any question that comes in your mind, I'm sure you may have, but let me now show you further operations of heap and its calculations. You can see here there is another example, but it's not a heap. Why? You can see here 12 is the minimum value, but you can understand it's not a complete binary tree. It's like half. It's a binary tree, but it's not a complete. Why? Because the left should be filled. This 40 should be here. Then it is a complete binary tree, and you could call it a mean heap. All right. So take a look at these example operations. I'm going to discuss the operations on heap based on this, and I'm sure you will have a better understanding of this. Let me discuss this very interesting operation. For example, we have a heap. 15 is at the root, and then we have 18, we have 25, we have 19, 20, and 30. So you can see it is a complete binary tree. Don't look at these 15 and 12 other numbers. I'm going to tell you how it is happening. This is a mean heap. Now this mean heap, we are going to insert something in this heap. Let's say I'm going to insert 12 in this heap. So it comes to the root and compare, is 12 is greater than 15 or less than 15. So if 12 is greater than 15, it comes to the right, like binary search tree. But when it comes to right, it says that 25 is greater than 12. But generally, the first thing what will happen is when I insert 12, it will directly come and stay here. Come and just get connected here. Why? Because of complete binary tree. Is that clear? Again, let me tell you. Suppose you are inserting 12 in this heap. What it will do first, it will first add this 12 to make this tree a complete binary tree. So you can understand the complete binary tree means you had one link missed. It's initially get connected here. You see, initially inserted 12 is here. Now you have the heap property is lost. Why? Because the minimum value is here. It should be at the root. It's a mean heap. So what you have to do, you have to actually heapify this. We call it heapify, means I have to reform the heap again. How do I reform the heap again? This 12, I'm going to actually swap with my immediate parent, which is 25. We call percolate up. That means I'm going to replace 12 here and bring 25 down here. Then 12 is here again. 12 is actually greater than 15. So percolate up again. So 12 comes at the place of 15 and 15 comes down at the place of 25. So how many percolation I did? One to go to 25, another to go to 15. Two percolation. Now this entire process we called actually heapify. Now let us take at the final look of the heap. The final heap is this one. You see 12 is at the root now, 18, 15, and then you have 19, 20, 30, 25. This is a complete binary tree. This is also full binary tree, but this is a min heap, and it actually proves that we have done the heapification and heap is structured. So heap is a data structure which is very widely used in Huffman coding and different algorithms. And if you have a specific question on the heap, you can ask me. But again, let me repeat again that heap is a binary tree, but it has a very specific property. We have min heap and max heap, and you can understand that this max heap, the maximum value is at the root. Heap must be a complete binary tree. The min heap is the minimum value is at the root, and you understand the operation of the heap. So I hope you enjoyed this lecture. We discuss in the Google Classroom.